Now see a first normal mode of vibration. First normal mode of vibration. We can take here L is equal to n lambda by 2. That means we can write lambda is equal to here 2L by n. If we are taking here n is equal to 1, then it means L is equal to lambda by 2. So, for the first normal mode of vibration we have taken n equal to 1. So, L is coming lambda by 2. It means in the string wavelength is being formed, that is the whole length is L here between these two ends. So, now the wavelength which is being formed, it is like this. So, this point is representing antinode, this is representing node, and this is representing node, and this one is representing here antinode. So, when the string vibrates in this way, or you can say in the first normal mode of vibration, it has got two nodes and one antinode, and this whole length is vibrating in one segment, and its wavelength is equal to lambda by 2 here. Now, in this case we can get also frequency. So, frequency is equal to, we know it, velocity is equal to frequency into lambda. So, we can write here frequency is equal to V upon lambda 1. Lambda 1 is here for the first one, normal mode of vibration, and lambda 1 can be written here, that is 2L from here. So, we can write nu 1 is equal to V upon 2L, and this frequency is called, this is the minimum frequency, and this is called fundamental frequency, and the sound or note produced in this frequency, or in this case, is called fundamental note or first harmonic. So, now if you are putting n is equal to 2, you will be getting second normal mode of vibration. So, in that case we can write here lambda L is equal to here 2 n lambda by 2 here. It means if you are writing n is equal to 2, you will be getting here lambda 2. It means the length of the wire is equal to wavelength of the stationary waveforms. In that case, the wire vibrate in this way here. This is the first antinode, second antinode, and this is the node, first node, second node, and this is the third node, and this one is first antinode, and this one is the second antinode, and this whole thing is equal to lambda 2 is equal to here L. Now, in this case frequency can be written here V upon lambda 2, that is here V upon here L, and that can be written 2 into V upon 2L, and we can write nu 2 is equal to twice of nu 1. This frequency is double of the frequency in the first normal mode of vibration, and here we can write, if you keep on getting the frequency in the different normal mode of vibration, you will be getting nu 1 is ratio, nu 2 is ratio like this, is 1 is to 2 is to 3 like this, if you are taking a nu 3 also here. So, in this type of the ratio you will be getting of the frequencies in the different normal modes of vibration.